Alright, logic for mathematics, creating truth tables. This presentation is created by me, Kira Wood. So in any language, sentences or statements are complete thoughts. So in mathematics, we want to figure out whether a sentence is true or if it's false. So for example, we could have 3 plus 4 equals 7, which is a true statement, but 3 is greater than 4 is a false statement. So we can create truth tables to verify whether a statement is true or false in regards to mathematics. So a truth table is a way we can formalize component statements that are represented abstractly by letters. Here's an example of how you would set one up. In order to construct this truth table, let's think of it in terms of English. So if you were to say, I have a dog and a cat, in math, we could have A represent the dog, and we could have B represent the cat. Now, in order to prove the truth in this statement, we can construct a truth table. Okay, so we are trying to prove that A and B are true. So remember, we started out with our sentence in English that we have a dog and we have a cat. So we're letting A represent that we have a dog, and B represents that we have a cat. And A and B represents that we have both. And this right here is the symbol of and. All right. So we will need to construct a table with 3 columns, so that's going down, and 4 rows. 1, 2, 3, 4. Okay, so in order to determine this, we need to figure out, is it true? Let's say it's true that we have a dog. So we can mark in this area right here, we could put a T for true. Okay. Now let's say we don't have a cat. So we'll have to mark that false. Now, do we have a dog and a cat? No, we don't, because we're missing one of them, so we can mark that as false. So in the next scenario, let's say that we have a dog and we have a cat, so we can mark them both true. And then do we have A and B? Do we have both a dog and a cat? We do, so we can mark that true. Now, just let's say for kicks, let's say we don't have a dog. Let's mark that false. And let's say we have a cat, so let's mark that true. Now, do we have both A and B in this scenario? And we don't, so let's mark that false. Now finally, our last scenario would be that we don't have a dog and we don't have a cat. So therefore we would not have A or B, or A and B in this sense. So in order to be true, to prove that we have A and B, we need both components of A and B in order to say that it is true. Alright, but what if we are trying to see who has a dog or who has a cat? So in this case, we can let A represent having a dog, and we can let B represent having the cat. Now let's construct a truth table to see what components make the statement true. Once again, we're going to need 3 columns. Put your A or your dog at the top of the first column, your B or your cat at the top of the second, and your A or B. Now, the V, it's not a V, it's just a little symbol that means or. So we can write or up here too, if you feel better with that. Okay, so we're also going to need our 4 rows. Okay, now, let's say we have a dog, so that's true. And let's also say we have a cat, so we'll put true. Now, do we have A or B? So do we have a dog or a cat? yeah, that's true. We have one or the other. So let's say we don't have a dog, but we have a cat. Then do we have a or B? Do we have a dog or a cat? Yes. So that's also going to be true. Now let's say we have a, so we have a dog, but we don't have a cat. So say false. In that case, do we have one or the other? We do, so we're going to mark that true. Now, finally, let's say we don't have a dog. We'll mark that false, and we don't have a cat. So in this case, do we have one or the other? We don't, so we're going to mark that false. So therefore, the only way an A or B statement can be false is if you're lacking both A and B. So in conclusion, we can use truth tables to see what components make a statement true or false in mathematics. If we are trying to prove the statement A and B is true, we need both components of A and B. And if we have only A or B, our statement becomes false. So in contrast, if we are trying to verify that the statement A or B is true, we only need one component or the other. And the only way for it to be false is if you do not have one component and the other, and if you don't have the other. So that is it. Thank you for watching.